Good morning, Tehmina Khan is here in TKMaths S1. In this series of videos, I have explained the topic function, which is a part of the syllabus of O-level additional mathematics and AS-level mathematics. The first 4 videos have the common concept which both year needs to know. And from video number 5, it is separate for each year group. So let's begin. And you can see here in the bottom my website address and my blog address. If you want to see more videos related to it, you can visit these sites. So let's see in the O-level AdMath syllabus, you can pause the video here and look into detail. But what I'm talking about here, only one concept is not in AS level from here. Sorry, rather two, I would say. Modulus function and the function of trigonometric and a logarithm function. They are not part of the syllabus of A-level mathematics. The rest of the things are present in A-level mathematics, AS level. Similarly, if you look at the syllabus of P1, there are two things which are not part of AdMaths syllabus. Those are domain and range of the composite function, which are a little complex, and transformation of the function with respect to this. So these two aspects are not the part of the syllabus of O-level AdMaths. So let's just start with the situation where function is applied. Usually it is said, what are the real situations? So all functions, definitely the variable in it represents some factor in the real life. So if you look at the example here, temperature of hot drink over the period of time as it cools down, the height of the valve of a bicycle tire while it is running on the road, the depth of the water in the conical container, the number of bacteria present after the start of the experiment. So in different field, in bio, in chemistry, they are all used, right? So these are the situations, just a few examples, which you can model them and then solve it. You need to understand here few terms when you're studying function. One term is mapping. What is mapping? So mapping is basically a relation between two sets of number. Now what type of relation? I have taken here one example. For example, I give you one number, I'll take it. I multiply it by 2 and then I add 1 in it, right? So this is the relation between the answer and the output and the input. So for example here, if these are the numbers which are my input values, right? So if these values have this operation on them, then what will be the output? So these input values are called domain in function, in the language of function. So input values are called domain. So if I do -2 multiplied by 2 plus 1. Now here is the example. -2, and this is the operation we were talking about here, right? So I am applying this operation on this function. I get output -3. So this output value is called the range. So do not mix it up with the concept of range, like usually the understanding of range is from this value to that value, right? Here, when we're talking about function, we mean range is the output value. So if you apply on each of these domain, this relation, this will be your range values for each one. So for every input, you will get, sorry, it is here. For every input, you will get only one output. For -2, you got -3. For -1, you got -1. You can try this out by using this relationship. So this is called mapping, that mapping of this onto mapping of this set. Now, mapping are of different types. Sometimes they give you only one relation, sometimes two relation. Like for example, here, I took the example, I did not define any expression to you. Now I will take an example here also. So if your mapping is such that for one value of input, you get only one value of output, or if there are two different inputs which gives you same output, then those type of mappings are called function. And we will see the example of this in a while. So I'm repeating here. When you substitute one input, you get only one output. But when you put two different input and you get one output, same output, then it is called a function. Function is written in these ways. You can see y is equals to x square, f of x is equals to x square, or f of x is such that it is x square. So these are the ways you can write function. Sometimes students make mistake of reading it as f multiplied by x. It doesn't mean that, right? It means this function is expressed in terms of x, right? Okay. So we have seen that the input set is called domain and the output set is called the range. And here is the example that how do you apply it. You might have seen that in the O-level mathematics, that if it is written f of 3, it means in function f you will replace x by 3 and you will get the result output. So this is called range, or it is called image, and the value you have plugged in the formula and the function is called domain. Now, how you will see it is a one-to-one function or it is many-to-one function, right? This is very important. So this test, which is called vertical line test, is very easy to figure it out. Now, for example, this graph and this graph, if you see, right? When you draw vertical line anywhere, let me draw more line. For example, I draw a line here. I draw a line here. It will cut the graph only at one point, right? So this is called, what it is called? It is a function. If I cut it like this, and if it cuts the graph at 2 points, so one value of x is giving you two values of y, like one will be here, another will be here, for the same value of x. So this is not a function. This is a function, this is not, because the definition of function is for every input of x, there should be only one output of y. So for this value of x, you have one output. For this value of x, you have one output. So vertical line test is a quick and easy way to figure out is the function representing, is the expression representing function or not. But this is for understanding. It doesn't mean you will sketch the graph for every time and then draw the vertical line. Right? Sometimes graph is given to you and they ask you, is it a function or not? Is it representing a function or not? So there you can apply this technique. So for example, if you look at this, and if you draw a vertical line here, right? It is a one-to-one function. For every value of x, you have one value of y, so it is a function. Now many-to-one. For example, if I draw the line here, if I draw the line here. So it is a function. But what does it mean by many-to-one? Let me just erase this line from here. It means for one value of y, you will have different values of x. So for example, if I pick up, suppose this value of y, I get this value of x, I get this value of x, and I get this value of x. So different values of x, you see, these are different values of x. They are giving you same value of y. So many-to-one is a function because the definition of function is for every input, there should be only one output. It doesn't say that that output cannot be the output of any other x, right? So every input, there should be one output. So this definition is fulfilled. So it is a function, but because that value of y is the output of other values of x also, so it is called many-to-one. Let's see here. If I take one value of x here, just for example, right? So I get one value of output here and one value of output here. So this is not a function. And secondly, vertical line test also prove that it is not a function because it is cutting the graph at more than one point. Similarly here also. So you can immediately answer that either the graph is representing a function or not. Okay. Now, what is the importance of one-to-one function? We will see later in the inverse function, which is the requirement. I am showing you here with the help of these graphs also with the line thing that is it representing one-to-one or not. For every input, you can see there is only one output. For every input, right? The arrow is showing that this is your input and this is your output. And it is written here also. So yes, it is one-to-one function. If you see here, two different inputs are giving you same output. It is many-to-one function. And you can read this language here. I have written this here so that you get used to of comprehending it through definitions, through explanation. Now one-to-many. The sketch will be something like this. And we will look at this again in the inverse function. So now this is not a function. Remember, this type is not a function. This type of relation is not a function. So one-to-many is not a function. So this is a linear sketch and this is a quadratic sketch. And we will see when we are talking about polynomial in a course, we will see linear, quadratic, cubic, and we will work around them. So now this video is finished, and in the next video I'll explain what is the meaning of domain and range in terms of function. We understand what domain and range is, but how to find the domain and range of a function we will see in the next video. So thank you very much for watching it. Please press like and subscribe button and share it with your friends. Thank you. Take care.